If you look back through the billions of years of Earth's history, you realize that the ground beneath you is anything but stable. Our planet has been a molten ball of fire, a frozen wasteland, and a jigsaw puzzle of continents that are constantly crashing into each other. I'm Mike with List 25, and today we're looking at 25 geological facts from Earth's history that'll shake your beliefs. 25. The Mediterranean Sea was once a desert. About 6 million years ago, the Mediterranean Sea completely dried up in an event known as the Messinian Salinity Crisis. Because the Strait of Gibraltar was closed off due to tectonic shifts, the sea was cut off from the Atlantic Ocean. In the hot, dry climate, the water evaporated faster than the rivers could refill it, leaving behind a massive, deep basin that sat thousands of feet below sea level. It wasn't a sea at all. It was a giant, scorching salt desert. Scientists found evidence for this by discovering massive layers of salt buried deep under the sea floor. Eventually, the Atlantic Ocean broke through the barrier in what is called the Zanclean Flood, sending a massive wall of water back into the basin. 24. Earth was once a snowball. Long before humans existed, Earth likely went through a period where it was completely covered in ice from pole to pole. This theory, known as Snowball Earth, suggests that roughly 700 million years ago, the entire planet froze over, including the oceans at the equator. This happened because of a runaway cooling effect. As more ice formed, it reflected more sunlight back into space, which made the planet even colder, leading to even more ice. What makes this fact so unsettling is the idea that even the tropics weren't safe from ice. Life only survived because of volcanic activity. Eventually, volcanoes pumped enough carbon dioxide into the atmosphere to create a massive greenhouse effect, finally melting the ice. If those volcanoes hadn't erupted, Earth might still be a frozen, lifeless marble floating in space today. 23. The mountains of the deep. Did you know Earth's longest mountain range is actually underwater? It's called the Mid-Ocean Ridge, and it wraps around the entire globe like the seams of a baseball. This massive underwater chain stretches about 40,000 miles. It's formed by plate tectonics, where the Earth's crust is literally pulling apart, allowing magma to rise up and create new seafloor. What makes this even more astonishing is that we spend so much time exploring the surface of the planet, yet the most dominant geological feature is hidden under miles of water. Most of the peaks in this range are thousands of feet tall, and the ridge is so large that it accounts for nearly 90% of all volcanic activity on Earth. Knowing that there's a continuous chain of mountains and volcanoes stretching across the bottom of the ocean makes our dry land mountains look small by comparison. 22. Antarctica was once a rainforest. About 90 million years ago, during the Cretaceous period, Antarctica was actually a lush, temperate rainforest. Scientists have discovered fossilized pollen, roots, and even evidence of ancient trees buried deep beneath the ice. Back then, the Earth was much warmer due to high levels of CO2. And even though Antarctica was still near the South Pole and experienced months of darkness, it was warm enough for dinosaurs to roam through dense forests. That transformation forces you to rethink the very nature of the continent. We view Antarctica as an ice continent, but for much of its history, it was green. The shift from a rainforest to an ice sheet happened because of the movement of tectonic plates, which isolated Antarctica and created the Southern Ocean current that trapped the cold air. It's a powerful example of how much the planet's personality can change, depending on where the continents are sitting and what's in the atmosphere. 21. Rocks can flow like liquid. We think of rocks as the ultimate symbols of being solid, but deep inside the Earth's mantle, rocks behave more like a very thick liquid. Because of the intense heat and pressure miles below the surface, the rock in the mantle isn't brittle, it's plastic. Over millions of years, this solid rock slowly churns and flows in a process called convection. This movement is actually what drives plate tectonics, carrying the continents on its back like rafts on a slow-moving river. This is essentially the foundation of all geology, but it's still hard to wrap your head around. If you could watch Earth's history and fast forward, the ground would look like a boiling pot of soup. The mountains we climb and the ground we build on are just the thin, crusty skin sitting on top of a massive, flowing interior. Realizing that the ground beneath you is technically moving at the same speed your fingernails grow is a strange thought that changes how you view the stability of the world around you. 20. The Great Dying was a geological event. About 252 million years ago, the Earth experienced the Permian-Triassic extinction event, often called the Great Dying. While we often think of extinctions as biological events, this was triggered by a massive geological catastrophe. In what is now Siberia, a series of colossal volcanic eruptions occurred, known as the Siberian Traps. These weren't your typical mountain-shaped volcanoes. They were massive fissures in the earth that poured out millions of cubic miles of basaltic lava, covering an area roughly the size of the United States. What happened next shows just how destructive the planet's interior can be. The eruptions released so much carbon dioxide and sulfur that the oceans became acidic and the global temperature spiked by about 18 degrees Fahrenheit. It wiped out 96% of all marine species and 70% of terrestrial vertebrates. When you look at the rocks from this period, you can actually see the transition from a world full of fossils to a dead zone. 19. Diamonds aren't actually formed from coal. One of the most common geological myths is that diamonds are formed from highly compressed coal. In reality, most are much older than the Earth's first land plants, which is what coal is made of. Most diamonds were formed between 1 billion and 3.5 billion years ago, deep in the Earth's mantle, about 100 miles below the surface. They're brought to the surface by extremely rare, high-speed volcanic eruptions called kimberlite pipes. It changes the story of a diamond from a piece of squashed trash into a time capsule from the Earth's infancy. Diamonds are basically pieces of the deep mantle that have been delivered to the surface at supersonic speeds. If the magma didn't travel fast enough, the diamonds would actually turn into graphite on the way up due to the pressure change. So when you look at a diamond, you aren't looking at old coal, you're looking at a geological survivor that has endured billions of years and a violent journey from the heart of the planet. 18. North America is still bouncing back from the Ice Age. During the last Ice Age, the weight of massive glaciers, some 2 miles thick, was so heavy that it actually pushed the Earth's crust down into the mantle. It's a process called isostatic depression. Even though those glaciers melted about 19,000 years ago, the crust is still slowly rising back up to its original position, a phenomenon known as post-glacial rebound. Parts of Canada and the northern United States are currently rising at a rate of about 0.4 inches a year. Even today, the geography of the continent is technically still changing because of the weather that happened thousands of years ago. In some areas around the Great Lakes, this rebound is actually shifting the water levels and changing the flow of rivers. It proves that the Earth's crust behaves more like a memory foam mattress than a solid brick. 17. The Grand Canyon is a geological gap. The Grand Canyon is famous for showing millions of years of Earth's history in its colorful layers. However, there is a massive gap in the record known as the Great Unconformity. In some places in the canyon, you can put your hand on a line where 500 million year old rock sits directly on top of 1.5 billion year old rock. That means over 1 billion years of geological history is simply missing, eroded away, and vanished into thin air. We rely on rocks to tell us the story of the past, but the Grand Canyon proves the Earth can delete its own diary. 1 billion years is about a quarter of the Earth's entire existence, and in this specific geological boundary, it's just gone. Scientists are still debating where all that rock went, with some thinking the Snowball Earth glacier scraped it away. 16. The Earth's magnetic poles flip regularly. We rely on the Earth's magnetic field to use compasses and protect us from solar radiation, but geological history shows that the North and South poles aren't fixed. They actually swap places every few 100,000 years. Scientists know this because when lava cools, the iron minerals inside align themselves with the current magnetic field, locking in the direction like a tiny frozen compass. By looking at the sea floor, geologists can see stripes of rock where the magnetism points in opposite directions. The unsettling part is realizing that north isn't permanent. The last flip happened about 780,000 years ago, which means we're technically overdue for another one. During a flip, the magnetic field weakens significantly, which would cause chaos for our modern satellites and power grids. 15. The Mediterranean Sea refilled in less than 2 years. I previously mentioned that the Mediterranean was once a desert, but the way it refilled is even more shocking. About 5.3 million years ago, the barrier at the Strait of Gibraltar finally gave way. This triggered the Zircon flood, which is considered one of the most massive floods in the planet's history. I mentioned all that. Instead of a slow trickle, water from the Atlantic came roaring in with a discharge rate that was 1,000 times greater than the flow of the Amazon. What's hard to grasp is the speed of that transformation. Scientists estimate that at its peak, the water level in the Mediterranean basin rose by more than 30 feet every single day. The entire sea, which is over 2 million square miles, was likely filled back up in a period ranging from a few months to 2 years. 14. Mount Everest is made of ancient marine limestone. When you stand on the summit of Mount Everest, the highest point on Earth, you are technically standing on an ancient seafloor. The rock at the very top of the mountain is yellowish limestone that contains the fossilized remains of marine creatures that lived in the ocean hundreds of millions of years ago. That detail alone reveals the raw force of plate tectonics. These rocks were originally formed at the bottom of the Tethys Ocean. When the Indian plate began crashing into the Eurasian plate about 50 million years ago, the seafloor was buckled, folded, and pushed upward nearly 6 miles into the sky. It shakes your beliefs because we view mountains as permanent towering giants. But Everest is essentially a piece of the ocean floor that got lost on its way up. 13. The African humid period turned the Sahara green. We think of the Sahara Desert as the ultimate symbol of heat and sand, but just 6,000 to 11,000 years ago, it was a lush landscape of lakes, rivers, and forests. This era, known as the African humid period, was caused by a slight wobble in the Earth's axis that changed the way the sun hit the northern hemisphere, strengthening the African monsoon. Geologists have found evidence of ancient riverbeds and megalakes, one of which, Lake Megachad, was once larger than all the Great Lakes combined. Very few things challenge our assumptions more than a green Sahara. During this time, it was home to hippos, crocodiles, and even early human civilizations that left behind rock art depicting a green world. When the Earth's orbit shifted again, the monsoons moved, and the region dried out in just a few centuries. 12. Earth's first atmosphere was toxic to humans. If you had a time machine and traveled back to the earliest days of Earth, you wouldn't be able to breathe the air. The planet's original atmosphere was mostly composed of volcanic gases like carbon dioxide, nitrogen, and water vapor, with almost no oxygen at all. It took billions of years for a biological and geological event called the Great Oxidation Event to change the chemistry of the planet. Primitive bacteria called cyanobacteria began producing oxygen as a byproduct of photosynthesis, which eventually reacted with the rocks in the air to create the atmosphere we have today. For most of its existence, Earth was completely unrecognizable to human life. The planet was a hostile environment that would have killed a human instantly. It also shows how geology and biology are linked. The iron in the Earth's crust absorbed the early oxygen for millions of years, creating massive banded iron formations that we now mine for steel. We are literally building our modern world out of the geological evidence of the Earth's first breath. 11. Zircon crystals are the Earth's time capsules. While we look at massive mountains and canyons to understand history, the most important geological evidence is actually microscopic. Zircon crystals are incredibly tough minerals that are virtually indestructible. They can survive being eroded into sand, buried deep in the earth, and even melted into new rock. Some zircons found in Western Australia have been dated back to 4.4 billion years, which is only about 150 million years after the Earth itself was formed. Incredibly, our understanding of Earth's birth comes from something smaller than a grain of sand. By analyzing the chemical makeup of a single zircon grain, geologists have discovered that early Earth cooled down and had liquid water much earlier than we previously thought. It shakes your beliefs because it means our entire understanding of the planet's formation doesn't come from a giant monument, but from a speck of dust smaller than the period at the end of this sentence. 10. The ground under your feet is moving at the speed of your toenails. We often think of continents as fixed, permanent masses, but they're actually floating on a semi-liquid layer of the mantle. Through the process of plate tectonics, these massive slabs of crust are constantly moving. On average, tectonic plates shift at a rate of about 1 or 2 inches per year. Coincidentally, this is almost the exact same rate at which human toenails grow. And while that sounds incredibly slow, Over millions of years, it's enough to move Antarctica from the equator to the South Pole. That slow drift means the world map is nothing more than a temporary snapshot. If you could sit in one spot for 100 million years, you'd see the horizon literally crawl away from you. This slow motion collision is what builds mountains and opens up entire oceans. Even though the Earth feels solid and unmoving, it's in a state of constant silent motion that eventually redraws every border on the planet. 9. North America and Europe are growing farther apart. Expanding on that movement, there's a giant zipper running down the middle of the Atlantic called the Mid-Atlantic Ridge. Here, two tectonic plates are pulling away from each other, allowing fresh magma to rise up and create new seafloor. Because of this, the Atlantic Ocean is actually getting wider by about 1 inch every year. This means every time you fly from New York to London, the trip is technically a bit longer than it was the year before. Every year, the Atlantic quietly widens without anyone noticing. And while it's expanding, the Pacific is actually shrinking, as its floor is tucked back into the mantle in other areas. It's a global balancing act. We think of the distance between continents as a fixed number we learned in school. In reality, the geography of our planet is being constantly updated by the volcanic activity happening miles beneath the waves. 8. Some rocks can actually sing. We usually think of rocks as silent, heavy objects, but there's a rare geological phenomenon known as phonolitic or ringing rocks. These are specific types of volcanic rocks, like those found in Ringing Rocks Park in Pennsylvania, that have a high concentration of iron and silica. When you hit them with a hammer, they don't give off a dull thud. They ring out like a metal bell or a tuning fork. Geologists have found that this happens because the rocks are under immense internal tension, almost like a stretched guitar string, and the vibrations can travel through them with incredible clarity. It's mind-blowing because it completely defies our common sense. You can walk into a field of boulders and literally play a song on them as if they were a giant natural xylophone. If you remove one of these rocks from the field, it often loses its ringing ability, suggesting that the way they're stacked and positioned in the ground plays a role in their acoustics. 7. Most of the Earth's gold is in the core. If you could take all the gold that has ever been mined in human history, it would only fill about 3 Olympic-sized swimming pools. However, that is just a tiny fraction of the gold that actually exists on Earth. Geologists believe that during the planet's formation, when the Earth was still a molten ball, heavy metals like gold and platinum sank deep into the center. There's enough gold in the Earth's core to wrap the planet's entire surface in a layer 1.5 feet thick. We view gold as a rare surface-level treasure, but it's actually a core-level component. We only have the gold we mine today because of massive asteroid impacts that occurred after the Earth's crust had already solidified, seeding the other layers with precious metals. If it weren't for those space rocks hitting us billions of years ago, we would have no gold at all. It would all be trapped 1,800 miles beneath our feet, completely out of reach. 6. The largest waterfall in history is under the ocean. When we think of waterfalls, we typically think of places like Niagara or Angel Falls. But the largest waterfall on Earth isn't on land at all. It's hidden deep underwater in the Denmark Strait, between Greenland and Iceland. In that narrow stretch of ocean, dense, freezing water from the Nordic Sea slips beneath warmer water and spills over a massive drop along the seafloor, creating a powerful underwater cascade that most people don't even realize exists. The water falls about 11,500 feet, more than 3 times the height of the tallest waterfall on land. It completely reshapes how we picture the hidden world. We tend to think of the ocean as a big, flat bathtub, but the seafloor has canyons, mountains, and waterfalls that dwarf anything we have here on the surface. This massive underwater flow moves about 123 million cubic feet of water per second. Even though you can't see it from a boat, it is a massive geological feature that plays a critical role in regulating the Earth's climate by moving cold water toward the equator. 5. The Earth's core is as hot as the surface of the sun. We often think of the center of the Earth as just a big ball of hot rock, but the temperatures of the planet's inner core are actually staggering. Scientists estimate that the temperature at the center of the Earth is approximately 10,800 degrees Fahrenheit. For perspective, that's roughly the same temperature as the surface of the sun. Despite being this hot, the inner core is a solid ball of iron and nickel, held in place by the immense pressure of the entire planet pressing down on it. Realizing that the temperature is comparable to the sun forces you to see our planet differently. Heat from the core is what drives continental motion and fuels every volcano on Earth. If the core were to cool down, the Earth's magnetic field would disappear, exposing us to deadly solar radiation. 4. India was once an island near Antarctica. If you look at a map today, India is firmly attached to the bottom of Asia. But about 140 million years ago, India was part of a supercontinent called Gondwana, located in the southern hemisphere near Antarctica. After breaking away, the Indian plate began a high-speed sprint across the ocean, moving at about 8 inches a year, which is lightning fast in geological terms. Eventually, it slammed into the Eurasian plate, and that collision explains why the Himalayas even exist. It was so violent that the Earth's crust buckled and folded upward, creating the tallest mountains on the planet. This process is actually still happening today. India is still pushing into Asia, which is why Mount Everest grows about 1/4 of an inch every single year. 3. The Grand Canyon is actually a recent feature. The rocks at the bottom of the Grand Canyon are nearly 2 billion years old, which leads many people to believe the canyon itself has been there forever. In reality, the carving of the canyon is a relatively recent event in Earth's history. Geologists believe the Colorado River only started cutting through those ancient layers about 5 to 6 million years ago. While the rocks tell a story of billions of years of history, the canyon itself is a newcomer. If Earth's history were a 24-hour day, the Grand Canyon didn't even start forming until about 11:58 p.m. It's a testament to the power of erosion. Even the most ancient and solid rock on Earth is no match for a persistent river and a little bit of time. 2. There's a giant ocean trapped inside the mantle. We think of the Earth's water as being in the oceans, lakes, and ice caps. However, researchers have discovered evidence of a massive reservoir of water trapped 400 miles underground in a mineral called ringwoodite. This isn't a liquid ocean you could swim in. Its water is trapped inside the molecular structure of the rock itself. Even so, it's estimated that this underground reservoir contains 3 times as much water as all these surface oceans combined. That discovery completely changes how we understand Earth's water cycle. It suggests that Earth's surface water may have originally seeped out from the interior rather than being delivered by comets. If this water were to ever be squeezed out of the rock and rise to the surface, only the tips of the highest mountains would be above water. 1. The moon was created by a massive collision. According to the giant impact hypothesis, 4.5 billion years ago, a Mars-sized planet named Theia crashed into the early Earth. The collision was so energetic that it completely melted both planets and sent a massive cloud of debris into orbit. That debris eventually clumped together to form the moon. It means the moon isn't just a rock orbiting us, it's a piece of the Earth itself. This impact also tilted the Earth on its axis, which is why we have seasons today. Without this violent planet-shattering event, the Earth would be a completely different place, likely without the stable climate that allowed life to evolve. That wraps up our list of 25 geological facts that prove the Earth is a lot more dramatic than it looks. If you enjoyed these mind-bending facts, you won't want to miss 25 strangest geological formations on Earth. We take a look at some of the most alien-looking places on the planet, from the eye of the Sahara to the giant crystals of Mexico. When was the last time you felt the Earth move? Let me know in the comments. As always, thank you guys so much. Don't forget to like, share, comment, subscribe, hit that notification bell so you don't miss out on any new content, and I will see you in the next one. Just gonna go really slowly as the Earth shifts me over this way. Oh, it looks better on camera. Whee! This is dumb. I'm going.